This is Higher 1, Chapter 3. In this chapter, we're going to be learning estimation, how to distinguish between an equation, formula, identity, and an expression, collecting like terms, substituting values, and how to solve linear equations. Now, estimation and approximation, these two words can be used interchangeably most of the times. Now, depending on what the question is asking, if the question only involves addition and subtraction, what we're going to do is round the numbers to the nearest whole number. Now here, in question 1a, we have 7.14. Now, the number that we're going to be focusing on is a 7, which is a units, and the number after it, which is a 1. The number 7, will it be rounded up or kept the same? Now that depends on the number after it. If it's 5 or more, you round the units up. If it's below 5, you keep the units the same. So what we're going to do here, we're going to keep the 7 the same. Now we have 2.93. Now 2, is it going to be rounded up or kept the same? So look at the number after. We have a 9, so we're going to round the 2 up, and that becomes a 3. Then 4.03, so the 4 is kept the same. And we have 7 minus 3 plus 4. 7 minus 3 is 4, plus 4, 8. Now we're going to do question 1c. Now here, this 8, can it be rounded up? Let's see. The number after it is 5 or more, so we can round the 8 up, so we're going to get 29. Plus, then we have 3.03, that becomes 3, minus, now the 5 does not get rounded, so we're going to have minus 25. The reason why is because we have a 1 after. So now you're going to do 29 plus 3, which is going to give us 32. Then 32 minus 25 will give us 7. Exercise 3.2. Question 1. Write down approximations to the following calculations. Now the word approximations is suitable, and so is the word estimation. So what we're going to do is round everything to one significant figure. Now the reason for that is whenever the question, you could have addition in 5 different places, but if you have one multiplication or division, you are expected to round everything to one significant figure. It simplifies the process and makes it a lot easier. Now, significant figure means what? Significant means important. So the most important number, the first significant figure, is going to be the first non-zero number. Now, what do I mean by non-zero number? So, for example, if I had 6,700, first non-zero number is 6. So that is my first significant figure. Then if I had 0.0067, the first significant figure is going to be 6. That is the most important number because that is the first number that has value. The zeros before have no value, but any zero after the first significant figure will have value. Until, well, of course, if you had, for example, 0.006007. Each of these two zeros has value. So, the first significant figure here would be 6, then second would be this, then third, and then fourth. So if I round the first number to one significant figure, now you're going to look at the number after the first significant figure. If the number is 5 or more, you round it up. If it's below 5, you keep it the same. So the number after the 6 is 7, so 6 gets rounded up, and you end up with 7. And the other numbers all become zeros, so you're going to get 7,000. Now here, the 6 is going to get rounded up, and you're going to get 0.006. Now the reason why you don't write the 7 is because this 7 has no value. So when you're looking at decimal numbers, any number that is rounded is kept the same. The number after it, any extra zeros you won't write. So the first question is going to be 9.3 times 0.845. Now the 9 is the first significant figure, and then you have the 8 here. as the first significant figure for the second number. So 9.3 is going to get rounded to 9, multiplied by 0.8. Now we do 9 times 8, which is 72. Carry the decimal place. Carry the decimal place. And you get 7.2. Now we're going to do question E. Round it all to one significant figure. So we're going to get 0.2 over 0.6. Now, we want to deal with whole numbers. So what we're going to do is multiply the numerator and denominator by 10. So we're going to get 2 at the top and 6 at the bottom. This can be simplified further into 1 over 3. Question number 2. Work out an estimate for the value of this question here. So the first step is to put the estimate sign. It's not a random squiggly sign. It's called the estimate sign or approximation sign. So what we're going to do is we're going to round everything here to one significant figure. So 6.18 becomes 6. 311 becomes 300. And 0.524 becomes 0.5. Now here, the denominator is a decimal number. We want to change that. We want to turn it into a whole number. So what we can do, we can times it by 10, turns it into 5, but something easier would be this. Times it by 2. I know 0.5 times 2 is going to give me 1 whole. So times the numerator by 2 as well. Now here, you don't multiply each individual number. You don't times the 6 and the 300 by 2. You would multiply the outcome of 6 times 300 by 2. So 6 times 3 is 18, then times it by 2, 36. Put the 2 zeros, 3,600. Now 0.5 times 2 is 1, and anything over 1, well, of course it doesn't change. So we're going to have 3,600 as our solution. Now question number 4. You're going to round it. We're going to get 400 times by 6 over 0.2. So to turn the denominator into a whole number, let's multiply it by 10. So times the top by 10 as well. So 400 times 10, 4,000, multiplied by 6, that's going to give us 24,000. Over 0.2 times 10 is 2. And when I divide it by 2, we're going to get 12,000 as our answer. Formula, identity, and expression. Now, an expression is a combination of terms which contain variables, constants, and coefficients. Now, a variable is any letter we can use from the alphabet, for example, X. Now, X can have any value. It could be 5, it could be 20, we don't know, it could be anything. If I write a number next to it, 2x, that is called a coefficient. And the coefficient tells us how many of these x's I have. Now this itself would be called a variable term. Any whole number after it, for example plus 7, is going to be called a constant. A constant meaning the value doesn't change. It will be 7 always. X can be whatever, but that 7 doesn't change. For example, if you wanted to substitute 2 into it, you would get 2 times 2, which is 4, plus 7, 11. So 7 would be called the constant. Now, to be able to distinguish between an expression and an equation, because you can have an equation where you would have 2x plus 7 equals to 11. You can solve it. That is the difference between the two. An expression can't be solved. An equation can be solved. So if there's an equal sign and one variable, it will be an equation. In this case, we only have one variable, which is x. If we had AR to the power of n equals to t. This would be a formula. Because look, we have 1, 2, 3, 4. 4 variables. So if you have more than one variable, it would be a formula. A common formula would be area equals to pi r squared. Now you have r as your variable and a as your variable. So if you know the value of r, you can work out a. So if you have 2 variables, you need to know 1 to work out the other. If you have 3 variables, you need to know 2 to work out the third. Now we have identities. An identity is a connection between 2 expressions that remain true for all values of a variable. For example, if I have 2 times x plus 1. When I expand this, we're going to get 2x plus 2. And the value of x will remain the same because we're representing it with the same variable. Both sides are identical, so when you simplify one side to get the next side, it's an identity. So for example, if you had 5x plus 10 over 5, and you simplify the fraction, and you divide the 5x and the 10 both by 5, you're going to end up with x plus 2. So what does that mean? It means that these 2 sides are identical. So instead of putting an equal sign, we can put an identity sign, which is 3 straight lines, not 2. Now, question number 1. It says match the left column with the correct answer in the right column. Now the first one says A, open bracket, B plus C, close bracket. Now we have 3 variables, but there's no equal sign. So it means that this would be an expression. So the absence of an equal sign automatically lets us know it's an expression. Now here we have V equals to IR. Now we have an equal sign and 3 variables. So if you have more than one variable, it's going to be a formula if there's an equal sign. Now the next one, you have 5x plus 4 equals to 2x plus 31. Now we only have one variable, meaning x. Even though it's present in both sides, it counts as one variable. If you had a y, then you wouldn't be able to solve it. Then it would still be a formula. But in this case, it's going to be an equation. So we're going to join it to equation. Now the next one. When you see the 3 lines, it automatically means identity. As when you expand the brackets, you're going to get 4a plus 4. So both sides are identical. So you join up the 2. Now the next one says, write down whether each of the following is an expression, an equation, an identity, or a formula. Now the first one, we have an equal sign, 3 variables, we know it's going to be a formula. The next one, we only have one variable, but we have the identity sign. So this is going to be an identity. The next one, there's no equal sign, and we can't collect the like terms, solve it, anything. So the absence of the equal sign means expression. Now this one says 2 and r equals 9. So n and r are 2 variables. So if you have more than one variable and an equal sign, this would be a formula. Next one would be an equation. And then identity. Now we're going to be collecting like terms. Now what does it mean by like terms? For example, if you had one banana and another banana, and now your friend brought over 2 bananas. Now 1 banana plus 1 banana is 2 bananas, and plus another 2 bananas is 4 bananas. Now it's called collecting like terms. So you have to be very careful when you're doing these, because you can only collect the same variable. So you can do 4x plus 6x, and that's going to give us 10x. But if you had a question where you had 4x squared plus 6x, you can't collect them. The reason being because x squared is not the same as x. So can't work it out. So if you had a question where you were doing 3 apples plus 2 bananas, now your friend brought over 4 apples and 7 bananas. How many apples and bananas do you have altogether? Now 3 apples plus 4 apples is going to give us 7 apples. 2 bananas plus 7 bananas is going to give us 9 bananas. Exercise 3.4. Now here they want us to collect all the like terms for each of the questions. So we're going to do question E first. So here we have a whole number, 8. We have A. We have minus 6B, minus 5A, 4, and minus 3B. Now what we can do, we can pair up all the like terms. So we have 8 plus 4. And then you have A, and you have minus 5A. So we have A minus 5A, then you have minus 6B, minus 3B. 8 plus 4 is going to give us 12. And A minus 5A is going to give us minus 4A. Minus 6B minus 3B is minus 9B. Now question F, we have 8j and minus 7j. Now it's not necessary for us to write all the numbers to all the like terms together. We can solve it in our heads. So 8j minus 7j is just going to be j. K, and there's no other k, so it's just going to be on its own here. Minus 2m and minus 3m is going to give us minus 5m. And plus 7 is on its own, so we just write plus 7 here. The diagram opposite shows a triangle. Write down an expression in terms of x and y for the perimeter of this triangle. Give your answer in its simplest form. What it means in its simplest form is to collect all the like terms. So to work at the perimeter of any shape, all we do is add up all the sides. So we're going to do 6x minus 2y plus 2x plus 8y plus 14y minus x. Now 6x plus 2x is going to give us 8x. 8x minus x is going to give us 7x. Minus 2y plus 8y is 6y. 6y plus 14y is 20y. And that is the perimeter of this shape. X 3.5 is on substitution. Now for this topic, all you have to do is replace the variable with the numbers given. So in question 1a, all you have to do is replace each of the variables with a set of brackets. So we're going to have 2 times x. X is what? 4. Y is minus 3. Z is minus 1. Now when there's no sign between a variable and a number, and a variable and a variable, it implies multiplication. So what it's saying in question A is 2 times x times y times z. So 2 times 4 is going to give me 8. Then minus 3 times minus 1 is plus 3. And that's going to give me 24. Now the next question is this one here. Question. X is going to be replaced with 4. you're going to put the plus sign. Y is going to be replaced with minus 3. And Z will be replaced with minus 1. Now nothing should change in the expression given to you. Each variable should be replaced completely with the number given. That's why we're going to be using brackets for simplicity. So 4 squared is going to give us 16. Minus 3 squared is going to give us 9. And minus 1 squared is going to give us 1. And when you add this up, 1 plus 9 is 10. 10 plus 16 is 26. Question number 3. Now, for this one, we're going to substitute u and v into the equation given to us. So we're going to have 1 over f equals to 1 over 2 plus 1 over 4. Now, the first thing we need to do is collect the two fractions. Now, to do that, we need to work at the LCM of the denominator, which is going to be 4. So times the denominator by 2 times the numerator by 2. So we're going to get 1 over f equals to 2 over 4 plus 1 over 4. And 1 over f equals to 3 over 4. But the question's asking us to work at the value of f. Now, to work at the value of f, you need to understand the concept of cross multiplying. Now, this can only be done when you have an equation, an equal sign, and a fraction on the left and a fraction on the right. Other than these two things, there should be nothing. So we're going to cross multiply, meaning the numerator and the denominator of the opposite sides will get multiplied. So 3 times f is going to be 3f. 1 times 4 is going to give us 4. And we take the 3 to the other side. F will equal to 4 over 3. And when you convert it into a mixed number, we're going to get 1 and 1/3. This is exercise 3.6, and this is on solving linear equations. Now, when you're solving a linear equation, what you need to understand is that we are going to be taking everything we don't need to the other side. So if we're solving the value of x, we're going to be taking the plus 3 to the other side. And if you're going to take anything to the other side, it becomes the opposite of what it is. So plus 3 would become a minus 3. So x will equal to 5 minus 3. So x will equal to 2. Now, what you need to understand is that we will be doing the opposite of BIDMAS when we're taking to the other side. So BIDMAS is brackets, indices, division, multiplication, addition, and subtraction. Now, you will usually deal with the brackets first. But in this case, we're not going to be doing that. We are going to be dealing with addition and subtraction first. So you're going to get rid of all the addition and subtraction first. Then you get rid of all the division and multiplication second. Then you deal with the indices and then the brackets. So what does that mean? That means that in question 4 here, we don't do anything to the 9. We don't move it, we don't touch it until this plus 4 here is gone. So you take plus 4 to the other side. 9x will equal to 31 minus 4. So 9x will equal to 27. Now we take 9 to the other side. X is going to equal to 27 divided by 9. X is going to equal to 3. Now in exercise 3.7, we're going to be applying the same concept as before. So we want to bring all the x's together. So if we have a fraction, like in question 4, we can't do anything to the numerator until the denominator is gone. So we're going to get rid of the denominator by taking it to the other side. Now divide 2 becomes times 2. So we're going to have 5 plus 3x equals to 2 times the whole of whatever's in the right hand side, minus 7 plus x. So we expand the bracket, we're going to get 5 plus 3x equals to minus 14 plus 2x. Now we want all the x's together, so we're going to be taking the plus 2x here to the other side, we're going to take this plus 5 to the other side. So you're going to have 3x minus 2x equals to minus 14 minus 5. That's going to give us x equals to minus 19. Question number 4. Steve is asked to solve the equation, and this is his working out. Now Steve's answer is wrong. What mistake did he make? So let's observe here. 5x plus 5 times x plus 2. So that means we're expanding a bracket. So we're going to be multiplying everything inside the bracket by 5. So 5 times x is going to give us 5x, which we've got over here. Then 5 times 2 should give us 10. Well, we don't have 10 here, we have 2. So that's a mistake he made. So Steve did not expand the brackets correctly, as 5 multiplied by 2 equals to 10. So if the question was 5 times x plus 2 equals to 47, expand the bracket, you're going to get 5x plus 10 equals to 47. Minus, take plus 10 to the other side, it becomes minus 10. So 5x is going to equal to 37. Take 5 to the other side. So if it's multiplying this case, it becomes divide when it goes to the other side. So we're going to have x equals to 37 over 5. Now 5 goes into 37 7 times, and our remainder is 2. And the denominator will remain as 5. And that is the end of chapter 3.